Hello everyone, my name is Nitin. Welcome back to my channel. In today's video, we'll talk about extract, transform, load, or in short, ETL. So if you are building any data warehouse, you must be aware of ETL pipelines. If you are a SQL beginner, I must tell you that this is one of the most important topic which you should understand thoroughly. If you are an experienced professional, I'm pretty sure this video will work as a very good refresher for you. As part of this video, I have covered the important points which everybody must know as part of ETL. Also, want to mention that these are not the only points, so don't think that it is a complete exhaustive list. But from my side, as per my understanding, whatever I feel is very important and are a must for any ETL developer, I have listed that in this video. So without wasting any time, let's start with the very first topic, which is extract. Extract basically means that you have to get data from your source. So whatever the source could be, it could be an OLTP sources running on some database solutions. It could be a flat file. It could be a hand-filled surveys. It could be anything. So for your data warehouse, there can be n number of multiple sources, and those sources can send you data in different formats. Extract phase means you have to get data as quickly as possible from your source. And how can we do that? So there are multiple ways by which you can achieve that. The most common way is using the flat files. So the source will extract data from their environment and they will send you it in flat file formats. If the source is running some typical database solutions as OLTP sources, they may even let you connect via JDBC and ODBC, and then you can connect to those sources and extract the data yourself. However, in some of the cases, because of data governance and security issues, the source may not allow you to connect directly to their servers. So in that case, they may extract the files, they will push files via SFTP to your environment, and we call it a landing area. And from there, you can consume in your tables. Now, with or the near real-time streaming or the real-time streaming has come into the picture. So now solutions like Kafka, Kinesis, all these supports real-time streaming. So if you are supporting a business where latency or the delay in consuming the data, or say for example, if you're working for a credit card business and there is a person who is visiting your website and who is inquiring about your different credit cards. So as a business partner, right, what you may want to do is reach out to that customer immediately as and when he is surfing your website. Because in a typical data warehouse, if there is a 24-hour delay and say next day you reach out to that person that yesterday you were on our website and you were interested in different credit cards, we have some offer for you, would you like to take it? Now, because of this delay, you may end up losing a customer. But at that moment, when he's actually on your website and you have real time streaming enabled and you are streaming the clickstream data into your systems and supporting your business in real time, that is one of the use cases I can think of. In that case, turning your potential customers into actual customers, it's very high. So depending on the business you are supporting, you may go for the real time streaming solutions as well for extractions and ingestion. And then there is a typical pipeline batch where on decided frequency, once a day or twice a day, once a week, the data will come to your environment and you will ingest it into your tables. So extraction basically means you have to get data dump from source and you have to do it as quickly as possible. That does not mean that it should be real time streaming all the time. There are other factors which determines that what will be the frequency of extraction and ingestion of the data. Now moving on to the next topic, which is no complex logic. So in extraction phase, which typically happens in the staging area, we do not apply any complex logic. So simple logic, like if you have date of birth, from there if you want to calculate the age of the customer, maybe that kind of logic you can implement in this staging area, which comes in the extraction phase, where you can apply very basic logic like determining the age. So no complex logic in the extraction phase. Next point is data format consistency. So what I mean by that is you may have multiple sources sending you data, and most of the time you may feel that there is a relationship between data sent by different sources. So here, say example, I have a gender column and source 1 is sending me male, female and others, right? Source 2 might be sending the same information, which is gender, but they may be using the convention MFO. However, source 3 could be sending it like 0, 1, and 2. Now, I cannot ingest all these data as is in my data warehouse, right? I have to have a data format consistency so that everywhere the same data is represented in the same manner. So I may choose in my target that I'll represent for gender column whenever any source is sending me gender values. I will apply some logic and I will keep it as MFO. The other example could be it's a very basic example where you apply some consistency into your date formats. So source 1 may be sending you data in this format YYYY hyphen MM hyphen DD. Similarly, source 2 could be sending data in their own format, and source 3 and source 4. So now in your target, you can decide that, okay, for any incoming date column, by default, I'll have this format. So you can apply some basic data format transformations on your incoming data in this extraction phase. The next point is the data quality rules. So in the extraction phase, you can also apply some data quality rules, like say your business has started from 2015 onward. So any sales you have made, you know that it should be after 2015, right? It should not be 2014 or before that, because your business was not even in the existence at that time. So you can apply this data quality rule that while ingesting any data, the source should be sending you data from 2015 onwards. So if it is not following this data quality rule, you can either push it to a error table so that you can report it to the source, or you can simply ignore such records. So that is one example. The other example could be that there are sometimes description columns, and we never use this description column in our warehouse, data warehouse, for any business or analytical purpose. We are just storing it. So in that case, probably just to save some storage space, right, and speed up the process, you may restrict it to the first 500 characters only. So you can apply that kind of a rule also. Say if you are getting a value for column 1, then column 2 should also have a value. It cannot be null. So that data quality rules also you can apply. So for example, if the source is sending you some data, and if the source has sales date in it, then probably you can check for the sales ID column also, that if sales has been made and you are getting a sales date value from the source, you should also get the sales ID for that. Else in that case it's a error record and you can move it to the error tables. These are some of the basic data quality rules also you can apply in this phase. Generally, the tables who are involved in the extraction phase, typical the staging tables, are truncate and load. So today file will come, you will truncate the table, you will load the today file, you will process the data. Tomorrow when the new file will come, you will delete the previous table completely, and you will load the fresh file, and then you will proceed with your ETL pipeline. So generally these are truncate and load. There it is not supposed to run any business queries. So in the extraction phase, right, the staging tables which are involved, you are not supposed to run any business queries on top of that. It is strictly for technical purpose only. It is primarily built to support your ETL pipelines, and you are not supposed to run any business queries. In fact, the business team should not be even given access to the staging area. Now, what can be the popular load strategies, right, for the extract? So it could be a full or it could be a delta. So if a table is pretty small, say a few hundred or even thousands of rows, the source may send you full data every time. So this actually reduces the overhead or the operations overhead of maintaining the incremental flow. So in that case, it's a small table. The source may end up sending you full table all the time. So in that case, you will simply truncate and load your final table. The other popular strategy is the delta. This is especially very good for the bigger tables where on daily basis you are getting hundreds and thousands of rows, and with time it becomes a very big table. So in such cases what happens, source generally identify what are the updated records, deleted records, or the new records, and they send only the changes happening to their table to you. And then you have to load this data into your staging area, and then you have to flag the records. In some cases the source may also send you the flag that I for insert and D for delete, U for update, like that. So this makes your life easy. But if the source is not sending you any flag, then in that case you have to load this data into staging table and compare it with your target table on the basis of primary key to determine whether it's a new record or it's an old record with some updates, and you have to apply update on the table. So those are two very popular load strategies in the staging areas. And the load approach, obviously when you are starting it for the first time, right, you will go for the historical load. So in that case you have to bring in all the data till date, and then you will load it into your tables, and after that you will run the incremental loads on daily basis or whatever is the frequency. So that is about the extract phase, guys. I hope you are clear that when you're working on the extract phase, primarily you are getting data from source and you're ingesting data into your staging areas. These are some of the very critical points you should be aware of, and these are the steps generally taken in the ETL pipeline for the extract one. Now moving on to the transform phase, right? Transform phase, what does this mean actually? So in transform phase, whatever data you have ingested in your staging tables, you will apply different data transformations or different data mapping rules on it to make it more meaningful. So in this phase, we'll start converting a raw data into meaningful information. And in transform phase, you can either have predefined set of steps that for any incoming data you will follow these steps one by one in sequence, and at the end of those steps you will have a enriched data which makes more sense to your business. So some of the common transformation steps I have mentioned in this video, it is not an exhaustive list, but as per my understanding these are the most important transformation steps which should be there typically in all the ETL pipeline. The very first step is the mapping. So mapping basically means source to target mapping. So when you're getting data from the source, right, they may be sending you data for 10 columns, and for every 10 incoming 10 columns there will be a mapping for those columns in the target table. So it could be as is mapping, where whatever the source is sending you data, you just move that data as is into your table without any transformation. Or it could be a column level mapping, that or it could be a new derived columns also. So say source is sending you first name and last name, and now in your business you want full name of the customer, so you may create a new derived column concatenating first name and last name and coming up with the full name. Similarly, you can rename the columns. Like source may be sending you emp underscore id for the employee id column, and in your case you want the full name, so you can change it to employee id, so you can rename the columns. So that's a typical example of mapping transformations. You can enrich the data. So what will happen, sometimes the source will send you some data which may not be very meaningful from your business perspective. So in that case you can do a quick lookup into some other tables and you can add some more information to it, so that the output is more meaningful for your reports, right? So one example could be the source could be sending you zip code, but the promotions your marketing team is running is at the city level. So what you may want to do is, rather than just storing the zip code, you may want to convert that zip code into a city level by doing a lookup into the table and then storing city value into your tables, right? Similarly, the third type of transformation is the join, where you have data into multiple tables and then you join those multiple tables and you load a single table by joining these tables. So this makes more sense because sometimes it happens that source are sending you data. Source may have different tables at their own environment also, and they are extracting it one by one and they are just sending you data. But for you, it makes more sense to club those data into a single table and then use it for reporting. So you may go for the joint transformations. Similarly, you can apply a filter transformation also. So say your source could be sending you a global data, like it spread across multiple countries, and the source is sending you data for all the countries in one file. Now you are going to support a promotion or a marketing scheme which is applicable only for North America. So in that case, if you're creating a data mart, or if you are bringing in data specifically for your North America continent, you may want to apply a filter in incoming data, so that you select only the North America data and then you move it to your tables, right? So filter is another very important transformation step during transform phase. The other is a very common problem actually, but I am pointing it here as a step because if required, right, if you are frequently facing this problem which is of remove duplicates, then probably you should add this as a typical step for all incoming data. So you should your ideally your ETL process should handle duplicate records, although it's not mandatory for you, but I think it is a good practice to have this check. Now, how duplicates can end up in your environment? One very common reason is the source has sent you the same file again, right? So, like today is say 20th, and source has sent you a 19th file again, right? So you will process the same file assuming that it is of 20th, but when you'll process it the same data, and if your ETL pipelines are not properly built, you may process the same data again. So if you consume the same data again, you will end up having a duplicate records in your tables, right, which may lead to data quality issues. The other reason could be that you might have run the same job again. So for 19th, you might have run the same job again, and now you have duplicate data into your tables. So your ETL pipeline should be designed in a way that you should be able to handle your duplicate records. Now, aggregation, when you are building your data warehouse, there will be times when you are calculating the measures, and these measures actually support your businesses. That okay, a business may want to know that how many sales have happened in a particular store in a given quarter. You may want to do some aggregation, which is equivalent to basically a group by clause in your SQL, and then you may want to come up with some numbers by adding those, coming up with sum or average, max, and min, and you may want to make your data more meaningful, right? So aggregation is one another very important transformation which you must be very well aware of, right? So this is about the transform. I hope I have covered all the important critical steps which happens during the transformation phase. If you feel I missed any, feel free to leave a comment below, and probably I'll try to add that as well. Now moving on to the last step, which is the load phase. So in the load phase, what happens is you have the data, you have extracted data from source, ingested into your staging tables, you have read data from your staging tables, apply a lot of transformation steps into it, and load it into intermediate tables. Now what happens is once you have data into your intermediate tables, these intermediate tables, typically what happens is in many scenarios enterprises don't want to have a separate data layers every time. So these intermediate steps, right, many times it will happen in the temporary table or the volatile table, which directly loads your dimensions and fact, right? So this is also a possibility. Now coming to the load phase, basically you will be loading your dimension tables, you will be loading your fact tables, you will be loading your EDW tables, and you will be creating data marts out of your data warehouse as well. So what are dimension tables? So this is not a specific dimension table video, but I'll tell you the key points as per me, that when you're loading a dimension table, these are the key points you should consider. So one is obviously the dimension table typically should have a primary key, and which are generally created using auto increment column or the identity columns in some RDBMS solutions, or you can call it as a surrogate key. So these are meaningless. These are just like the number 1 2 3 4 5, and you basically it is used to create uniqueness for each record, right? However, business wise it does not make much sense because these are purely technical columns, and these are like a sequence. Now a dimension table must also have a functional identifier or a natural key. So to explain it more, let me use some examples, right? So it does not mean that a functional identifier is always one row in each dimension table, depending on the load type of the dimension, right? Like in SCD2, where you will maintain the history, the primary key or the auto increment or the surrogate key will always be unique, but the functional identifiers may repeat, right? So say employee who have moved his city from Bangalore to Hyderabad, the employee will remain the same in your employee table, right? Though that information will remain the same, like his date of joining, right, his name and his PAN card, all these details will remain the same. Only his city, office city will change from Bangalore to Hyderabad. So the functional identifier may exist multiple times. However, the surrogate key associated with those functional identifier will still be unique, right? And this is unique for each row, but it may have multiple occurrences depending on whether you are maintaining a CD2 table or a CD1 table. The other thing dimension tables has the attributes. Attributes basically tells you that what information this dimension actually is storing. So it's like for employee is the dimension table. If you have an employee dimension table, it may have employee name, employee city, employee date of birth. So these are the basically the attributes of your employees. As I said earlier, a dimension has the load strategy. It could be SCD 1, 2, 3, or the hybrid SCD model, which is used to load any dimension table, whether you want to maintain history or you don't want to maintain history. And if your dimension is very small and kind of a static, not much changes are coming into that dimension table, you may even want to go for a truncate and load option for that dimension table. And granularity, whenever you're designing a data model, you have to make sure that your dimension granularity is properly defined, because if that is not well defined, then in that case, reporting, when you are creating a reporting and visualization on top of those dimension tables, you may not be able to reflect data in a proper manner to your business, right? So grain is one thing you should consider while loading any dimension tables. Next to dimension is the fact tables. So fact tables, if you know that it should have a primary key which is similar to the surrogate keys which we see in the dimension. So even the fact tables have the primary key or the auto increment identity columns or the surrogate keys. However, in addition to that, they also have a foreign key. So foreign key basically are the primary keys which are sourced from the source dimension table into the facts. So typically the dimension tables are always loaded first, and the fact table source the primary key of dimension table into it and reference them as a foreign key. So there is a foreign key relationship between primary key foreign key relationship between dimensions and fact. And fact tables generally have the measures like total sales, total revenue, where you will apply some group by, you will apply some aggregation functions like sum, max, min to calculate some measures. That being said, all facts does not have the additive property. There are some semi-additive and factless facts also, and non-additive facts also. But in general, fact tables generally have the measures, and we do aggregation. Those measures could be additive across all the attributes or across some of the attributes. Now that's about fact table. Next is the EDW. So this is your main business layer where you are storing all the EDW tables. So your EDW tables has the process data, which is very important for your business team to make any decisions. So these tables are generally exposed to the business or the reporting team or the BI engineers in your team, who will read data from these process data from these tables and will create reports on top of that. So EDW basically means it's a main data layer which supports the BI, and it has all the process data which is kind of an end of the ETL pipeline. So all the process data is also shared with the downstream applications, which could be reporting, or it could be some other team where you will export data from these tables into flat files and push it into there. So now, rather than acting as the consumer or the target, you will act as a source, and you will export the process data and you will push it to some other team which will now start their ETL pipeline or their consumption process. Similar to EDW, you can have data marts also. So sometimes you may want a very subject specific area where you can do your analysis. So in that case, you can derive data marts from your EDW. You will create separate tables in data marts, and you will source only subject specific data from your EDW and create data marts. And data marts are also used for reporting and visualization purpose. So that's it, guys. I wanted to cover this in today's video, that what is ETL, extract, transform, and load, and what all the key steps in each phase. I hope this video was helpful. If you are a fresher, I'm pretty sure you might have learned some new things today. And if you are an experienced professional, as I said earlier, I believe that this video was a good refresher for you. If you feel I missed any point here, feel free to drop a comment and I'll try to correct it. Thank you very much for watching the video. Thanks.